So we have interesting assignment. 4-point charges are individually brought from infinity and placed at the corners of the square shown in the figure. Each charge has the identical value of plus q. The length of the diagonal of the square is 2a. Okay, this charge is plus q, this is plus q, this is plus q, and this is minus q actually. Okay. So charge is q, but this one is minus q. First question was what is the electric field at the center of P? And then what is the electric potential at the center of P? So first of all, let us see what did I write. So I just place here, this is the electric field from this charge at this distance. And because that is positive, I just placed that much. That is a Coulomb constant, this is the Q, and this is the distance between those two things. And we have 3 positive and 1 negative, and I place that is 2Q, KQ divided by SE squared. Because that is the distance. Okay, and what is the electric potential at the center of P? So electric potential is that much. So and what is wrong? What is wrong here? We will get to the point B. Let us see first what is wrong at the point at A. A is correct result, but this does not make any sense. This is not correct. So I did wrong and get correct answer. How is that possible? Well, sometimes that does happen. Sometimes that is really happened. You make mistake and you get correct result. What was the mistake? When you talk about electric fields, electric field is vector. So you need to know what is the direction. What it does to this point here. So electric field due to this plus charge here is directed at this point is directed like this. That is E1. And electric field due to this point charge here, in this point here, is directed away from it. Because it is positive, and that is E2. And what now? What is overall electric field due to these two charges? Well, it is 0. Why? Because they are same at the same distance. So these two will cancel each other out. So E2 plus or minus E1, whatever. Let's say minus E1 is equal to 0. So there is nothing to. Okay, and now with this and this one. Electric field due to this charge here at this point here will be directed away from it. That is E3. And because this is square, and what will be electric field due to this charge at this point? Well, it will be the same by magnitude, and it is directed where? To it. One more, identical, E2. So overall electric field will just be 2 times KQ divided by A squared, because one of that is KQ divided by A squared. Did you understand that? These two combat each other and cancel each other out because they are same. These two work together and add. Why? Because they are in the same direction. And that's why we did get 2KQ divided by A squared. Now, what is the electric potential at the center of P? How do you calculate that? Electric potential is work equal to the work that unit positive charge is brought from the infinity to that point. And I will make a pause now to see what is the best way to describe this. for this part. So for this part here, there is nothing more to say, except that is how you do it. And without further ado, let us see where I derive my, how do you say that, quick references. This is hyperphysics from University of, I don't know, find it and find it yourself. This is very honest cross-section of whole physics. Excellent thing. So for the multiple point charges, at this point you just add them together. And that is all there is to it. And that is easy to calculate. And you can add them like that because it is, where did I read this? Voltage is a scalar quantity. And that's nice. So hyperphysics once again. They are very good. So find them if you want to know more. And that's all there is to it. This thing we did explain better, and now get good result with good explanation, and that's all there's to it. There's nothing more in PDF file, but if you want, you can donate, and for complete written answer, please follow the link in the description. If you want more of this, please subscribe and tell your friends. Thank you. Bye.